Hello everyone, welcome back to the channel. In this video, we are going to experiment on Goroutines. So we are going to create a program where the program will keep creating the Goroutines and then we'll observe how the program behaves. To check its performance, we'll also observe the CPU and RAM utilization, like what is the impact of Goroutines on the CPU and RAM. We'll also try to understand like what is the consequences of running n number of Goroutines and is there any parameters which we should observe before creating n number of Goroutines. So let's get started. So we are inside the main.go and we have a very basic program. So we have a main function which is running from 1 to 100,000 and this is going to call this consume function. So what this consume function is doing, it's like it's just sleeping for 10 seconds. So it is kind of behaving as a process. So this main function will call the consume 100,000 times and each function we are going to initiate in a separate go routine. Now the 100,000 go routines are running and we have to give it some time so that all the go routines can complete its execution before the main go routine exit. So for that we are going to use the wait sync and for each go routine we'll add increment the counter by 1 and then we'll wait, and to decrement the count what we are going to do, we'll pass this wait group to the consume function. So we are going to pass the reference of it. So once the function has completed its task, it will call the done function which will decrement the count by 1. To monitor the performance properly, so what we are going to do, we are going to use the Docker. I have created a very simple Docker file. We are using this Golang Alpine as a base image, the app directory as the working directory. We are copying our main.go file. Then we are adding the default command as go run main.go. Now let's build the image using Docker build command. So Docker build, and we are going to give the image name as grex. So go routine experiment and the dot. So it has created the image. Okay, so this particular image we are going to use in a docker compose file. uh, so this is a small docker compose. So in this the service name is gr image, we are using the grex, and here we are mapping the volumes. So what we are doing is like this main.go file we are copying in the app directory. So suppose if we make any change here, like suppose from the 100,000 iteration we just want 10 iteration, so we can simply do it instead of again building the docker file. In the docker compose file we can also define the few more configuration like deploy. So using deploy what we can do is like we can restrict the memory usage and the cpu usage, like this particular container how much memory it can use. So these things we will see, suppose if we have given only the 100 MB or 120 MB of memory to a particular container, and if we try to exceed more than that, then what happens? So all these things we are going to observe in this particular lecture. To monitor the container performance, we are going to use an extension. We are going to use this resource usage docker extension to monitor the container performance and the CPU utilization and different other things. To run the program we are going to use docker compose up command. So when we'll run it, as we can see the CPU utilization has increased and memory usage is also increased, and it is around 300 MB right now. And after some time, 10 seconds, the program will end and the program is exiting with zero code. So the zero code is like a status code 200 you can consider, or like a successful, like there is no error. So now let's test how it will behave when we'll restrict the memory to suppose 100 MB or 120 MB. So for this, what we are going to do, under deploy we have the resources, then the limits. So limit signifies like the maximum limit or like the upper cap. So here the memory is like 120 MB and the reservation is like memory of 100 MB. So what reservation mean is like the minimum this much memory must be allocated to the containers, and suppose if that much memory is not available, that time it will not start. So let's just save it and let's again run it. So let's just clear it, and now if you'll see it has recreated, and so memory utilization is 100% around, and we can see like it has killed the container and it exited with the code 1. So this is the drawback of keep creating the go routines. So it will keep occupying the cpu and ram, and there are possibility like suppose if there is go routines which is kind of stuck for certain response or something, and if it kind of stuck, it will keep occupying the RAM memory, and eventually your container will crash. To prevent such kind of scenarios, you can follow a few good practices. Like the first one is like always use the worker pool. If there is any use case where you have to create multiple routines, always use worker pool. Or there is one more way you can try. So you can calculate how much time a go routine is taking. So suppose if it is taking 100 milliseconds, then you can create the go routines at an interval of suppose 300 milliseconds. So that will give certain time to it. Like the old go routines will complete their execution, and eventually the RAM will always be available for the new operations. So that is one practice you can follow, but again, that's kind of risky. I hope you like this lecture. Thanks for watching, and I'll see you in the next lecture.